Molar mass. Objectives. Define molar mass. Identify molar mass of elements. Calculate the molar mass or formula mass of compounds. The relationship between the number of particles and atomic mass. A carbon-12 atom, by definition, has a mass of 12.000 AMU, or atomic mass unit. It was determined that 1 AMU has a mass of 1.67377 times 10 to the minus 24 grams. For a carbon atom, 12 AMU, that would have a mass of 1.9926 times 10 to the minus 23 grams. So a carbon atom would have that mass in grams. Now, to weigh that amount of that atom, it would be extremely difficult. So instead, we need to use something more tangible. So multiplying by this number, 6.022 times 10 to the 23rd, that amount of atoms weighs 12 grams. That number, that magical number, 6.022 times 10 to the 23rd AMU is equivalent to 1 gram. It's a conversion factor. This magical number is also known as Avogadro's number, or the mole. Therefore, 1 mole of carbon atoms would have a mass of 12.000 grams. Now, how do we use this in our everyday weighing or counting of atoms? In the periodic table, we have the atomic mass for all the elements. For example, carbon. Carbon has an average atomic mass of 12.01 AMU, rounded to the hundredths place. Now, this 12.011 is the atomic mass, or 12.01 grams per mole. We can relate the atomic mass to something tangible, grams, where 6.022 times 10 to the 23rd atoms of carbon has a mass of 12.01 grams. So, if we were to count 6.022 times 10 to the 23rd atoms, they would have a mass of 12.01 grams. We should work some example to clarify this further. Molar mass. Recapping from the last slide, 6.022 times 10 to the 23rd carbon atoms has a mass of 12.01 grams. Or we could say a mole of carbon atoms has a mass of 12.01 grams, because a mole is 6.022 times 10 to the 23rd. By definition, the mass in grams of 1 mole of a substance is known as its molar mass. For example, the molar mass of carbon is 12.01 grams. The molar mass of elements. The molar mass of an element is its atomic mass expressed in grams. For example, if we were to determine the molar mass of calcium, we would go to the periodic table, we would identify the atomic mass for calcium, and then we would express it in grams. 40.08 grams. That would be the molar mass for calcium. Practice. Determine the molar mass of 1 mole of magnesium. Here we would go to the periodic table. We would identify the atomic mass for magnesium, which is 24.31 rounded to the hundredths place. And that would be the molar mass for 1 mole of magnesium atoms. A common misconception is to mix up the atomic number and the atomic mass. For example, the molar mass of magnesium is commonly reported as 12 grams instead of 24.31 grams. So please be aware of that. Another practice. Determine the molar mass of 1 mole of sulfur. First, we go to the periodic table. We identify the atomic mass for sulfur. Then, we round it to the hundredths place, 32.07 grams. That would be the molar mass for sulfur. Molar mass or gram formula mass for a compound. The molar mass or gram formula mass for a compound can be found by multiplying the molar mass of each element by its subscript in the formula and adding the results. For example, to determine the molar mass of any OH, we will need to identify how many atoms of each element is present and multiply that by its molar mass. So let's do Na. Na has an atomic mass of 23. Expressing it in grams for its molar mass, it would be 23.00 grams. There is a subscript of 1 next to Na, which is understood. Therefore, we multiply that mass by 1. The result is 23.00 gram. For oxygen, the molar mass is 16.00 gram. We multiply it by 1, since there's only one oxygen atom present in the formula, for 16.00 gram. And finally, for hydrogen, the molar mass is 1.01 grams. We multiply it by 1, since there's only one hydrogen present, for a mass of 1.01 gram. Then we add it all up. For the total mass, here we have 40.01 gram. The molar mass of any OH is 40.01 gram. It is the sum of all the molar mass of the elements present. A practice. Determine the molar mass of MgCl2. In this example, we have one magnesium atom and two chlorine atoms. First, we tackle magnesium. The molar mass of magnesium is 24.31 grams. We multiply it by 1 because that's how many magnesium atoms we have in the formula. And we have a total mass of 24.31 grams. For chlorine, the molar mass is 35.45 grams. There are two atoms of chlorine, so we multiply that mass by 2, resulting in 70.90 grams. Adding them both up, the total mass is 95.21 grams. The molar mass of MgCl2, magnesium chloride, is 95.21 grams. Another practice question. Ethene and hydrogen can react at a faster rate in the presence of the catalyst platinum. The equation below represents a reaction between ethene and hydrogen. The question asks us to determine the molar mass of the product. The first thing we need to do is identify the product. The product is found on the right side of the equation. So our product has 2 carbons and 6 hydrogen atoms. First, we tackle our carbon. The molar mass of a carbon atom is 12.01 grams. There are 2 carbon atoms, so we multiply it by 2, resulting in a mass of 24.02 grams. Next, we tackle our hydrogen. The molar mass of hydrogen is 1.01 grams. There are 6 atoms of hydrogen. Therefore, we multiply it by 6. The resulting mass is 6.06 grams. Adding the molar masses up after multiplying, we have the total mass as 30.08 grams. The molar mass of the product is 30.08 grams per mole, because 1 mole of C2H6 has a molar mass of 30.08 grams. Concept checked question 1. The sum of the atomic masses of the atoms in 1 mole of C3H6Br2 is called the formula mass. The formula mass gives us the masses of all the atomic numbers. It is also commonly referred to as the molar mass of a substance, and the unit is gram per mole. Question 2. A 1 mole sample of krypton gas has a mass of... Looking at the periodic table for krypton, we identify the atomic mass for krypton. We express that in grams to give us the molar mass of the sample, which is 84 grams. Question 3. What is the mass in grams of 1 mole of oxygen gas, O2 gas? Here we have a unique situation where you just don't look at one atom of the element. Oxygen exists as diatomic, and in the question they're asking us for a molecule of oxygen gas. So we need to determine the mass of 2 atoms of oxygen. So the molar mass of 1 atom of oxygen is 16.00 grams. There are 2 of them, we multiplied by 2, and the resulting mass is 32.00 grams. So our answer is 32.0 grams. Question 4. The gram formula mass of NH4Cl is? In this question, we are asked to find the gram formula mass or the molar mass of NH4Cl. Here, we have to identify each element. We find their molar mass, and then we multiply it by the subscript at the bottom of that element. For nitrogen, it's 1, so we have 14 grams. For hydrogen, the molar mass is 1 gram, but there are 4 hydrogen atoms present, so we multiply it by 4. The result is 4 grams. For chlorine, the molar mass is 35.5 grams. There's 1 chlorine atom present, so we multiply that by 1, resulting in 35.5 grams. We add it all up, our total mass is 53.5 grams per mole. Question 5. The mass in grams of 1 mole of CaSO4.2H2O, calcium sulfate dihydrate. The first step to solve this problem is to identify the molar mass for all of our elements and add it up. In the first step, we do it for CaSO4, the anhydrous component that is without the water. So for calcium, it's 40 grams multiplied by 1, 40 grams. Sulfur, 32 grams multiplied by 1, 32. And for oxygen, 16 grams multiplied by 4, since there are 4 oxygen atoms present. The total mass is 136 grams. The second part of the question is to get the mass for the 2 water molecules present. So, there's actually 2 hydrogen atoms, 1 gram each, for a total mass of 2. There's 1 oxygen atom for a total mass of 16. The mass for 1 mole of water is 18 grams. Therefore, for 2 moles of water, it will be 36 grams. Step 3, we add the mass for the CaSO4 to the H2Os. The total mass is 172 grams, and that's our answer. Question 6. The gram formula mass of calcium hydroxide is? (74 grams). This is obtained by identifying the different elements present, how many they are, and multiplying it with their respective molar masses. For calcium, molar mass is 40 grams. There's 1 atom of calcium, so we multiply it by 1 for a total mass of 40 grams. Oxygen, 16 grams is the molar mass. There are 2 oxygen atoms present because the subscript 2 outside of the parenthesis of the OH governs both the hydrogen and the oxygen. So, 16 grams multiplied by 2 is equal to 32 grams. For hydrogen, the molar mass is 1 gram. We multiply it by 2. We have 2 grams for a total mass of 7. Question 7. The gram molecular mass of calcium phosphate. First, we need to identify the elements present, get the molar mass, and then multiply it by their subscripts. For calcium, the molar mass is 40. There are 3 calcium atoms present for every formula unit, so we multiply it by 3 for 120 gram. For phosphorus, there is phosphorus in the parenthesis with a subscript of 2 outside, which means there are 2 phosphorus atoms present. So we have 31 grams multiplied by 2, which is 62 grams. For oxygen, there are 4 oxygen in the parenthesis, and there are 2 phosphate molecule. Therefore, we multiply the 4 by 2 for a total of 8 atoms of oxygen present. So, the molar mass of oxygen is 16 grams, multiplied by 8, because there are 8 atoms of oxygen present, which is equal to 128 grams. The total mass, when we add it up, is 310 grams. Therefore, choice 3, 310 grams is our answer.